Okay, guys, today is 5.3 position, velocity, and acceleration. So let's get started. If you remember some of this from physics, it'll make it a whole lot easier. Okay, so first up, let's do a warm up that you might remember from physics. Okay, so I have a distance time graph. It's a meters, y axis is measured in meters, and the x axis is measured in seconds. So find the velocity at t equals 3. So if you remember from physics, to find the velocity on this graph, what you would be doing is you would be doing the slope. So rise divided by run. So if you wanted to find the velocity at 3, like this is saying, you would put a point at 3. Okay, and then you would kind of look at what the slope is. In this case, the slope is very easy. The slope is 0. So velocity at 3 is 0 meters per second. Let's do the velocity at another point as well. How about we do it at 1? Okay, so at 1. So it's right here. Now if you notice, the slope for this whole thing is the same the entire time. So what you might want to do is pick a lattice point or something like this. This is sort of a lattice point. You could do this one. You could do this one. And let's go here. It looks as though I didn't choose the easiest graph to do this with. So let's do our rise over run for this. So the rise is 0.75. 0.75 over, that's meters, 0.75 meters for every 1.5 seconds. Yeah? So that would be a half a meter per second. Oh, that's a 2 meter per second. Yeah? And that would be the velocity at 1 because this slope is a half the entire time. Yeah? It's 0.75 over 1.5. This is 0. And then you can figure out your velocity here by figuring out the slope of that line as well. Okay, so remember that's how you do it in physics. Now, so notice what we're doing is we're taking a meter or a distance time and we are looking at the slope, which if you take this into calculus, what that means is we're looking at the derivative, right? So let's think about this. So if you have that, that means that, and for some reason, they give what is the slope of a derivative of position? What is the slope of a position? That is going to be velocity, right? So that means that the derivative of position is velocity. And for some reason in calculus, they like to use s for position. I mean, but you could also use x. Okay, so x prime of t is equal to velocity. And the same thing here, the derivative of position is equal to velocity, yeah? So this is telling us that the derivative position is equal to velocity. So that's something you need to put into your notes. That's a very important point. The derivative position is velocity. Okay. Now, is speed the same as velocity? This is something you remember from physics. And I would hope that you would say no. Speed is not the same as velocity. Speed has no direction, while velocity does have direction, which means that velocity can be positive or negative, right? It can be going forward or backward. Speed doesn't tell you which direction it's going. It just is a magnitude. It's just a number. So in this case, we know that speed is the absolute value of velocity, okay? So if velocity is -5, speed would just be 5. And let's give an example here. So let's say that velocity is equal to -5 meters per second. Then your speed would just be 5 meters per second. It wouldn't be telling you that it's traveling backwards because this negative is just telling you that it's going backwards, okay? Speed would not tell you which direction. Okay. Last thing here, what does the negative and positive velocity mean? And that's just what we were talking about right now. The negative tells you that it's moving backwards. The positive tells you that it's moving forwards. Okay, so what do you think the slope of velocity is? Okay, so if you, what we were just talking about right now, the slope or the derivative position is velocity. If you guys remember from physics, if you're given a velocity time graph, and you calculate the slope of that thing somewhere, that tells you acceleration, right? The slope tells you acceleration. So the derivative of velocity is acceleration. So that's something you need to write down. There's a bunch of different ways we could write it, yeah? So the derivative of velocity is acceleration, or the second derivative of position is acceleration. The second derivative of position is the same as the derivative of velocity, which is acceleration, yeah? All these are saying the exact same thing. Okay, so what does negative and positive velocity mean? I think I messed up here. I meant to put acceleration. Okay, so what does negative and positive acceleration mean? Well, a negative acceleration means that it's decelerating. Yeah, it's decelerating. Positive acceleration means that it's accelerating. Okay, so let's go forward. Okay, so we're going to work through some problems here. This is like a free response, how they might ask some free response questions. So, position of a particle is given by this function. Oh, whoops, my bad. Okay, so we have a function, and this function tells us the position of some particle at any given time. Find the velocity at t equals 1. Is it traveling to the left or to the right at this point? Okay, so if we want to find the velocity of this is a formula for position. We're going to need to find the derivative of this. So let's do the derivative over here, and I'll call it s prime of t, or we can call it velocity. Okay, so the derivative, what that would be is we would bring down the 3, it would be 3t squared over 3 minus 2t minus 8. That would be the derivative, right? And we can simplify that to just be t squared minus 2t minus 8. Okay, so if we want to find the velocity at 1, we can just plug 1 into that. So velocity at 1 is just going to be 1 squared minus 2 times 1 minus 8. Let's figure out what this comes out to be. 1 minus 2 is going to be negative 1, minus 8 is going to be negative 9. So it's going to give us a velocity of negative 9. And then it asks, is it traveling to the left or the right? Well, it's traveling to the left, since the velocity at 1 is negative. Okay. Find the acceleration at t equals 2. Is it accelerating to the left or to the right at this point? Well, let's see here. Find the acceleration at 2. Well, to find acceleration, we need to take the derivative of velocity, right? So we need to take the derivative of this thing right here. Well, the derivative of that would be 2t minus 2. Okay, and if we want to find the acceleration at 2, we just plug in 2. So we're going to have 2 times 2 minus 2. There's a lot of 2's. That's going to be 4 minus 2, which is 2. And is it accelerating to the left or the right? Well, in this case, it is accelerating to the right. So accelerating to right, because acceleration at 2 is positive. Okay, find the position at 3. Well, if it just wants to know the position, that's our original function. It wants to know it at 3, so we're just going to plug in 3. So s of 3 is equal to 3 cubed over 3 minus 3 squared minus 8 times 3, which this would give us 27 over 3, which is 9, minus 9 minus 24. And these two would cancel each other out, leaving us with the negative 24. So I know that the particle is at a negative distance, a negative position from where it had originally begun at time equals 3. Okay, now I need to keep all those things that I have here. I'm going to give you a couple more questions here that we're going to work on. Okay, now, whoops. I'm going to need to bring back those formulas that we just had. Okay, so here I'm just going to recreate them real quick. The velocity was t squared minus 2t minus 8, and the acceleration was the derivative of that, which is 2t minus 2. Okay, find the average velocity from 0 to 3. Now remember, if you see the word average, that's not the same as just finding velocity, okay? Average, whenever you see the word average, that's saying to do it the old-fashioned way, the algebra 2 way of doing this, or algebra 1 even. The f of b minus f of a all over b minus a. Now we want to find average velocity, right? So in order to find velocity, if you remember your physics, you're not going to be using velocity here, okay? Because velocity, if you use velocity on top, like let's say I did that, I use v of 3 minus v of 0 all over 3 minus 0. What that would give me is it would give me a velocity divided by the bottom, which would be a time. Velocity divided by a time. This is going to be average acceleration. So what we want to do is we want to actually use position. Remember, to find velocity, it's position divided by time. So we're going to do x of, or in this case not x, s, because that was what it was given in, s of 3 minus s of 0 all over 3 minus 0. Okay, well we actually figured out what s of 3 was, right? On the last slide it was negative 24 minus 0. If you plug in 0 here, that's going to be 0 minus 0 minus 0. Everything's 0 all over 3, which is going to give us a negative 8. Okay, that's our average velocity. And since it didn't give us units to use, I'm not going to use any. Most likely they'll be in like meters per second or something. But our units were not given, so you don't need to denote any units if they're not given. So in this case, find the average velocity is negative 8. Okay, find the point where the particle comes to rest. Okay, so think about this. When does a particle come to rest? That means that the particle has stopped, right? This rest thing means stop. Okay, something stops when its velocity is 0. So in order to figure out where something comes to rest, we want to set the velocity equal to 0. So velocity is t squared minus 2t minus 8 equals 0. That's how we're going to figure out where something stops. Now, they could ask you other things that are very similar to this, like where a particle comes to rest. You're going to need to use your thinking cap here sometimes, you know? When does a particle come to rest? You're going to have to think about, well, what would I be using? Would I be using position, velocity, or acceleration in order to determine when it stops? In this case, velocity is going to tell me when it stops, when velocity is 0. Okay, I'm going to have to factor this in order to determine the answer. Okay, so I'm going to have a t and a t. And it looks like I'm going to use either 8 and 1 or 4 and 2. 4 and 2 look like by far the better choice. And I need it to be a negative, so I'm going to have a negative 4 and a positive 2. Okay, that means I'm going to have answers of 4 and negative 2. Okay, now when does it come to rest? Okay, these are times, right? Negative time doesn't really make sense. So we're going to say that it came to rest at t equals 4. That's when the particle comes to rest. We can just ignore negative 2 because a negative time doesn't make sense. There shouldn't be any time before 0, okay? So find when the velocity of the particle is equal to negative 5. Well, when velocity is equal to negative 5, that means we're going to set velocity, which is that same equation we just had, we're going to equal it to negative 5, right? We're going to have to figure this out. Let's add the 5 over. So we're going to have t squared minus 2t minus 3, because we add the 5 over. And then looks like we can factor again. And we're going to have t and t. And we have 3 and 1. Okay, it looks like this is going to have to be the negative and this is going to have to be the positive. Okay, and we have answers of 3 and -1. Okay, so find when the velocity of the particle is equal to -5. Well, remember, we're going to ignore the negative time answers. We're going to say that it equaled -5 at t equals 3. Now, remember, you would make sure to use seconds or whatever units were given to us, but in this case, it did not give us units, so I'm going to ignore them. And that's when the velocity was equal to -5. And that's everything.